or set up an appointment before school and we'll take care of it. Alright, unpaired electrons. You need to be able to tell me the number of unpaired electrons in a ground state atom. So, for example, if I give you nitrogen, okay, if I give you nitrogen, I want you to be able to tell me how many unpaired electrons it has. First, you need to know how many valence electrons it has. So if you remember, this is one valence electron, everything in this column has 2, everything in this group has 3, 4, 5, 6, 7, and 8. And you can know that that's group 1, group 2, group 3A, 4A, 5A, 6A, 7A, 8A. So you can look at it that way and know. So when I find nitrogen, okay, everything in this group has 5 valence electrons. Okay, now I need to make my electron dot structure. So remember when we do that, I usually like to start here at the top and I make a dot, and I'm going to go around and do 1 in each orbital before I come back and do my 5th one. So I want to put 5 around it. 1, 2, 3, 4, and 5. So if I'm looking at this, looking at my electron dot structure I have here, the number of unpaired electrons is going to be 3. And the way that you can know that, here's an unpaired electron, it doesn't have a partner. Here's another one, it doesn't have a partner. Here's another one, it doesn't have a partner, it doesn't have a pair. Here, that's a paired electron. So in this case, it would be 3. And I'll go ahead and just give you the answers for all of these, so you can kind of try to work them out yourself. But nitrogen is 3, oxygen is going to have 2, fluorine's going to have 1, neon's going to have 0, carbon's going to have 4. Okay, so that's how you should be able to go through that and find the number of unpaired electrons. Moving on. Alright, electron dot structures. I just showed you how to do those. I can show you really quick again for like silicon here. Si, I find out how many valence electrons it has. So it's in group 4A. So I'm going to say it has 4 valence electrons. So I'm going to do 4 dots, and I want to do 1 on each side before I add 2 to any side. So that would be your electron dot structure for silicon. You should be able to do that for any of these on here. I'll let you kind of try to figure those out on your own. If you want to come in and ask questions on them, you can. But basically, this is how you need to be able to do it. What I don't want you to do, and I'll show you here, what I don't want you to do is, you know that phosphorus has 5 valence electrons. I don't want you to say, okay, here's 1, 2, 3, 4, 5. That's wrong. You do that and you're going to be wrong. You need to put 1 on each side, and that has to do with N's rule as well that we learned earlier, that you half fill an orbital first. So you do 1, 2, 3, 4, and 5. And so this was wrong. Okay. So let's move on again. Metallic character, basically you just need to know what this is showing right here. You need to know that metallic character is going to decrease as you move towards the alkali metals, and it's going to increase as you go down a group. So as I go down a group, things become more metallic, and that has to do with having more electrons in the sea of electrons that metals use to bond to one another. So that's what you need to know about metallic character. Going from left to right, it's decreasing metallic character. Going from the top to the bottom, it's increasing metallic character. Alright, Lewis structures. This is what we've been going on this is what we've been going over more recently. There's a few of these problems that are going to actually be pretty easy. For example, I have fluorine, sulfur, nitrogen, and aluminum up here as examples. Basically, for just those, you're just writing an electron dot structure. So fluorine has 7 valence electrons because it's in group 7A. So I'm just going to write my electron dot structure, which is 1, 2, 3, 4, Okay, 5, 6, 7, and I don't want that last one. Scratch that. Your final product, I just kept counting and went crazy there. But the way it should look is 1, 2, 3, 4, 5, 6, and 7. Alright, so you should have just one unpaired electron for fluorine. So those are going to be the ones that are a little bit more easy. You're also going to have ions, so you might have one with an ion. So if I have chlorine and it's Cl minus, what that minus tells me is because we know that the charge of an electron is negative, that means that if I have -1, then I have one extra electron. So chlorine has 7 valence electrons, so it has 7 valence electrons plus the one that I get from my negative charge. So I take that negative charge and I say, yep, +1. And so what you should see then is chlorine, instead of having 7 around its structure, it's going to have 8. And pretty much for any ion, any negative ion or an anion, that's what you're going to see, because that's the point of an ion, is to get to that octet rule and that full valence shell. So that's what you need to be able to do for those. Obviously, one of my dots didn't show up. There you go. And then also, you need to be able to do Lewis structures from compounds. And I think I have that on the next slide here. Some examples here. Be able to draw Lewis structures for compounds. I do want to try to go over all of these, so I'm going to go over them, and you're just, if you already know this, you can fast forward through it, but I want to go through as many of these as possible so that you can see as many examples as possible. So for water, okay, so for any of these, the first thing you want to do is an inventory. Okay, so I have hydrogens and I have oxygens. Well, when you take inventory, you have to know how many, right? So I have 2 hydrogens, I have 1 oxygen. So what I'm trying to do here is I'm trying to count up the total number of valence electrons that I'm going to have in my Lewis structure. So I need to multiply these numbers by the number of valence electrons that I get from the periodic table, which I've talked about earlier in this video. So hydrogen has just 1 valence electron, whereas oxygen has 6 because it's in group 6A. So I multiply those out, and then I add what I have together. So I have 8 total valence electrons to work with for water. Okay. My next step is to bond my atoms together. Okay. Oxygen is going to bond to my hydrogens. And I kind of went over why oxygen is going to be in the middle in class, and I don't really have time to really delve into that on here, but that's something that you can come and ask me, or maybe send me an email and I'll get to you on that. So, we've learned that everything wants to be happy. Everything wants a full valence shell. Okay? Basically, that means it needs to follow the octet rule. That means it wants 8 electrons to be happy. The only exception to that for this is hydrogen has a full shell if it only has 2. Okay? So each bond here is shared electrons. It's 2 shared electrons. So my hydrogen's happy because it's already sharing 2. My other hydrogen's happy, it's already sharing 2. I've drawn up there a total of 4 electrons in the form of my bonds. So I have 4 left to use. Oxygen's not happy. It only is sharing 1, 2, 3, 4 electrons. It wants 8. So in order to have 8, we're going to add the other 4 electrons I have to this structure right here. Okay? And this right here is the Lewis structure for water. So that's all that you have to do for something like that. The number of lone pairs it has 2 sets of lone pairs. It's got 2 bonding regions. Those are some things that maybe you should remember for whenever we get to, whenever I get to the Vesper theory stuff. All right. SF2, that's another one we can do here. So if I have SF2, first I'm going to count out my valence electrons, and I'm going to let you do that on your own, and I'm just going to go ahead and tell you that your total number of valence electrons you should get when you do it is 20. So we're going to be working from 20 valence electrons. So S is going to be my central atom, and we're about to get interrupted by announcements, which is so not cool. Alright, I'll try to get through this one and then I'll probably cut it off, and I'll either have to make another video or see if I can put them together. But basically what you're going to do is you're going to start with that. I subtract the 4 from my bonds. I have 16 electrons left. Now my goal is to make everything happy. The fluorine has 2. It needs a total of 8, so I'm going to add 6 valence electrons around it. Okay, I subtract 6 from that number there and I have 10 left. So I'm going to do the same thing to make this fluorine happy. Okay, so I'm going to make my fluorine happy. And then I have 4 left, and those are all going to luckily just kind of go onto my sulfur. Okay, everything's happy now, and I'm going to end it right there, and I'll get back to this later. Of the video that I just did. So let's move on to NO3 minus, so the nitrate ion. So when you're doing one of these types of, when you're trying to draw a structure for an ion or a polyatomic ion, you have to take into account that there's the negative. Alright, if there's a negative, that means there's an extra electron. Electrons are negative, so a -1 charge means that when you take your inventory, you pretty much just got to add another electron on there. Alright, so if we're doing it for NO3 minus, okay, first I take my inventory. I have 1 nitrogen, and there are 5 valence electrons because it's in group 5, remember. And then oxygen, I have 3 of them, and if I look, it's in group 6A, so I'm going to multiply that by 6, so that's 18. That's 5. I add that together and I get 23. And then I have to remember to add in my electron that I get from having the negative here. So it's +1, and I have 24 electrons to put into my Lewis structure. I'm going to have to make sure I use all of them, remember. So my next step is to draw out my bonds. So I have NO3, so I'm going to have 3 bonds to the oxygens. Okay, so I've used 6, so now I have 18. Next I'm going to try to fill or make sure that all of my outer atoms, so like my oxygens in this example, make sure that they all are happy. Alright, to make sure they all have a full valence shell. So I want to make sure they all have 8 electrons. In this case, the oxygen already has 2 that it's sharing. So here's 1, or there's 3, 4, 5, 6, 7, and 8. So I've used 6 more dots. So I put on 6 more electrons, so that's 12. I do the same here on this O. And the same for this O right here. And I probably look like I'm crazy right now, so I'm like, alright, so now I have 0 left. I've used all 18 of those extra electrons that I have. I've used all of my 24, but not everything is happy. This oxygen has 8, this oxygen has 8, this oxygen has 8 valence electrons, but this nitrogen here only has 6. So what I'm going to do there is I'm just going to basically say, forget these right there. I'm going to say that those are not there, and I'm going to bring them down into a bond. Alright, so I hate to have to draw this all again. So I'm not going to draw all the dots. So on all of the oxygens, know that there's 6 dots on 2 of the oxygens. There's a double bond there. And then this oxygen right here with the double bond is just going to have 4. And usually you're going to put that in brackets and put that it's negative. That way you just kind of know that it's negative and that it was the ion that you're drawing a structure for.